All right.
So, shall we start then?
Yeah, we can start.
Hello everyone. Am I audible properly? Hello.
Hello. Yeah, there's some background noise, but you're audible.
You can hear you, but there is some echo.
Yeah.
Okay. Hello. My name is Rishav Kedia. Okay. And me with my co-host Ayush, we will be carrying on today with the topic stack, and we will try to cover 5 questions here, if time permits. And initially, like I'll just start with some like few questions here. And basically, we all know that stacks is a data structure, a type of data structure, and which have few operations like push, pop, and pick. And we are
Sorry,
aware, so I will directly
there is a
Rishabh,
lot
there
of
is some background noise actually.
Yeah, I think there's
Is
some
there some
background
fan or
noise.
something running or?
just a minute. Yeah, just a minute.
Not like that. That's fine. That's fine. Yeah.
Uh, I think it's okay now, or is it still there?
Still there.
No, there's still something there.
Yeah, now I think it's fine. It's not there. I'm so really sorry for this. Yeah. So, is it okay now?
Yes.
Yeah. So what I was saying, so directly like coming up to the first question that will pick up is like minimum stack. Just a minute, I'll just share the screen. Yeah. My screen is visible.
Yeah, it's visible, I guess.
So, yeah. Thank you. So the just will take a few minutes to go through the question once. Yeah. So yeah. Uh, so shall we start? Like, have you gone through the question once? Hello. Hello.
Yes. We can.
Yeah. Yeah. So basically, it's just a basic implementation of the stack, like all the operations. Here, just the question is asking us to design a stack, okay, where we have to do the following operation: push, pop, and top, and get min. So push is basically we are pushing the element in stack. Pop is removing one, and top basically where the top will be pointing. Just we have to return that element as an output, and get minimum will be the at that point of time what is the minimum value of the stack, so that we have to return here. Just considering this example once, example number one. Okay, like here first they are just the question is asking us to create the minimum stack, and after that they are asking us to push operation and then again push operation. So basically minimum stack operation and the push operation and the pop operation is not giving any output in this question. Okay, when question will be going on to just run null, and once they ask for get minimum or top, then we have to return the value at point of time. So here, if we see ki first minimum stack, so obviously we'll create the mini stack there, and the output will be null, and then we are pushing here -2 in the stack, and after that again we are going to push 0 and then -3, and then they are asking for a for get min, where we have to return till now whatever the element there in stack, that we have to return the get min value, and then they are asking us to pop. So the top element will be popped out because it work on LIFO or FILO, like last in first out or first in last out. And then they are asking, then the next operation is top. In at this point of time where the top will be pointing, just we have to return that the top element, and at last again that get min. So after popping the this element, whatever the now remaining element we are having in the stack, so we have to return the minimum value out of the out of value present in the stack. Yeah. So am I is there like any, am I clear with the question here, like example? uh,
Yes, yes.
so yeah, thank you. So anyone would like to suggest any idea or their approach here for this?
You can have two stacks, one that has the actual numbers and the other one that has the minimums at a certain point, like at the same level. And then when they ask you for the get min, you just pick the second one. And if they ask you for the top, you just pick the like the main one. And I think that
Yeah,
that's it.
yeah. That's the thing. And thank you for the sharing your idea. And yeah, even can we directly like jump to solution right now? And I prefer like C coding in C. Basically, I'm comfortable with Python and C. Yeah, yeah. So here, basically in C, well, first we are defining just a structure where stack one stack we are taking, and then we are taking one minimum as just we have as just question is asking us, and then we are just then after that we are creating that minimum stack mini stack. Okay, and this function will be returning the stack for this create this stack that we have created. Okay, and yeah, then in the push operation we just keep the top is like if the stack is empty, means top is at -1, we'll simply increase and put that x value in it, and simultaneously we'll put that x also in the minimum stack because that's the first element. And like the approach is same just now we have discussed, and then if the entered the x the element we are entering, it's less than the top, like whatever the top value in the stack we are having, if the entered element is less than that, then so if the element is less than that, then there we'll just compare. Okay, and if the input element is greater and element all is there, if it is less, then we'll just enter this x in the stack, and we'll store the minimum top -1 value at top -1 onto the stack. Okay, and if the top like an element we are going to enter is obviously less in the else condition. Okay, the top the element we are going to enter is less than the element present in the top, then that time obviously the x will be the minimum at that point of time. Okay, and so here mini stack we in this case here created a mini stack. So this is what we are doing here. We have created mini stack, and the output will be obviously null for this. And then there are three, sorry, then there are three push operation where we are putting -2, 0, and 3, -3. So after at this point of time, and yeah, so here actually for this question, like there can be two approach. One is linear in linear time, and another in constant time. And this question is asking basically for us in constant time. And I'll just suppose here we have a stack. So we have one stack here. Okay, and in linear time, what we can do just simply we can document the code is asking us, and we can run through the complete stack every time to return the get minimum value. And in that way we can like go for this in linear time approach. But why we are using a stack here? Basically, we can using stack can make us to do it in constant time, and there will be a trade-off with the memory here. And here there will be one point top will be there, which I have been we have initialized to -1. Okay, and yeah, basically this is the stack. So first in the here in the question, it is saying we have to create mini stack, that we have create one mini stack. We will create one and one stack. Okay, I'll just divide it, and yeah, I'll just do it here. It is a operations that question is asking, and here I'll just put the mini stack, this part, whatever the min value, I'll just do that here. Okay, yeah. So first the person is asking for creating mini stack that we have created there, and then the push -2. At this point we can enter -2, and obviously is the first element. So here also it will, in minimum also it will come -2, and the top will point to and the top will point to 0, and then again then 0 and minus. So here in 0, and then we'll compare which is the smallest, and okay, it's still -2, and obviously top will increase to 1, and then it is -3 at. So at this point of time we'll enter -3 here, and now if we compare all three elements here, the minimum we'll get is -3. Okay. And the top will change to 2. Basically this index 0, 1 and 2, and then question is asking to get minimum. So basically we have already stored the minimum value till now, so we'll return this -3 as the output here, and then the question is asking for pop. Obviously, like whatever the last input was there, pop that is -3 will be popped, okay, from the stack, and for the and then again obviously like -3 will also be here popped, and then we have to return the top. Okay, then we have to return the top. At this point, the obviously the top will point to here 1, and so the output will be 0 because the top is pointing here. So, and at last it is again asking for get minimum. So this at this point of time, get minimum will be -2. That is we have already stored at each point of time. Yeah. So this is the basically the approach using stack, and we can do it in linear time. And yeah, this is the. So if any doubt or any point of view, like anyone want to share any point here, discuss anything.
Yeah.
Hello.
Yeah. Yeah, I think there's still some network issue, Rishabh. I think I heard some noise as well. Maybe if you want to fix that.
Okay.
Or is it something you can want to call from phone?
Is it okay now?
Yeah, better.
Yeah. So was I clear with all the points that I have? Like I told, like was I audible and was I clear there?
Yes.
That's clear. But I think you can go a bit
So,
slow
okay.
down because of this network issue.
Shall we move?
Sometimes the voice breaks, but if you can go a bit slow down, I think that would be helpful in this scenario.
Sure.
Yep. Yeah, you can.
Sure. Yeah, okay. I'll slow down. So in this question, like anything like anyone would like to discuss, or shall we move to the next question?
So the trick is to keep the value and the minimum together at one level.
Yes.
In like every level we are keeping the track of the minimum. Yes.
So, but you are maintaining 2 stacks.
Yeah, by maintaining two stack.
Can you done with 1 stack and put a custom object there with the value and min?
Yeah, I think there is one approach where you can do this with 1 stack also. I'm not sure.
No, I think the trick is to keep the min and the value together.
Yeah,
So,
exactly.
Yes.
so if we have like, if we create our own class, something like that, and keep the val and min or a array.
Right.
0th index is the val, 1 is the min. Can
Yeah,
we done it that
exactly.
way?
Yeah. I think we can go with that approach also.
We can. Yeah, we can in structure only, like we can define that two thing, and yeah, we can
So
access that.
looks like your stack is right now is the integer.
Yes.
So what I'm saying is keep like custom object. I don't know how it might. Yeah, then it could have more memory in the stack.
Yeah, actually, you are
But
not saving any memory with that approach because you are just storing the other array in a single array. So
Yeah, that's there's no memory difference here, I guess.
Yeah, but only thing is that you can use 1 stack which will have the value as Asim said, like it can have a value as well as the minimum value at that point. So you have to pop twice if you want to get a min and go for the new min, right?
Something like key value you can do, yeah.
Yeah, I mean class can have 2 variables.
Yeah, exactly. Here in C you can use struct or something, yeah.
Yes.
I did a bypass. I didn't use a stack. I use a linked list. So
Oh, okay, yeah.
did in the same way, like keeping the min and the val together.
Yeah, I think linked list can be used as a stack. Yeah, I think that should also work. But in terms of complexity, you are not saving anything.
Yeah, complexity wise, it won't change. It would be complexity wise, anything is order of 1 only. You're just inserting and removing.
Correct.
Yeah, but for number of operations, it will be big of n. Like the number of.
How come?
When you build your stack, when you keep pushing the elements, so it will build. I mean, the min will be order of 1 for sure. Yes. After the stack is built, yes. Yep.
So how it would be order of n?
I mean, what I was saying is that overall the operations will be like pushing elements on the stack, right? So you keep on building the stack of size n, right? But your get min is of big of 1 because you have that access, right?
So
does that make sense?
So I feel like all the operations are kind of order of 1.
Yeah. I think all are constant time only because we have a track of top also. So using the top, I think we can do all the operations in order of 1.
Okay. Yeah. Yeah. Once you build the stack, yes. Yep.
Yeah. Like in 1 stack right now.
Yeah, anyone would like to share code or type
Hi,
in the
Rishav.
code in 1 stack? Yeah, please.
Can you scroll down a little bit?
Yes.
Mini stack push. Yeah.
Push.
So my question is, in the else part, if the input is greater than the minimum element in the stack, you are still pushing it. Do we really need this? Because we know that all the elements present in the stack are lesser than the input element. So, I mean, point is like you are growing both the stacks all together. So,
Yes.
but we only need to keep track of minimum elements in the stack. So Can't we do better than this?
No, like it can ask for the actually it is asking for that at some point of time top also. So that's why so because minimum will be the lesser than that, but top can be that value, the top, the greater value that we are entering.
No, sorry, it's difficult to understand because your voice was breaking.
Yeah,
But I think that my point is that we don't need to grow both the stacks all together. We just keep a track of minimum element, what would be the min element in the stack at present point of time. So we can save some space over there.
I think
Okay,
you're
just
correct, but at some point we might need to give top as the output, or we might need to pop also. So in that case, you'll be needing those elements. So I think if you're not keeping track of those elements, so
yeah, I think Ayush, I think the point is that the min stack, right? What you have drawn here. So you are keeping -2 twice here, which is not needed. I think that is the
exactly
point, right?
Yeah.
So your main stack will remain the same, like -2, 0, -3 in this example. Right. But your min stack can only have like the presence of -2 only once.
True.
Yeah.
Because then you can compare basically, like you can peek and then see whether.
But as per his implementation, he's not going to save any space, right? His implementation is just an array.
Yeah, he's using array as
not. Yeah, so that is okay, that right?
Yeah, I think that is very minimal thing, but it's a good point actually. I think there can be a discussion on this point overall in the interview.
I thought he's using 2 stacks, not array.
He's using array, right?
Array as a stack. I mean, he's using
array as a stack.
He's using an array, not a stack, because CA doesn't have a HTML.
Yeah.
Okay.
Yes.
By looking this as, I thought it was stack. My bad. Sorry.
No problem.
Yeah, array as a stack.
But actually, array as a stack.
Can we save space with any other approach? What if there is, like, let's say the first element is -1 and then everything is positive? That means the minimum is always one element, right?
Yes.
So is there any way we can save space?
You mean like the min stack what we have, like the point you were discussing, like we can reduce the size of it. But other than that,
reduce the size of the min stack where basically just put only the minimum value, right?
Yes.
Okay.
That was my exact point. So if the minimum, so you said that -1 is the first element and rest of them are positive. So why to grow your min stack? Just have -1. And every time if you look at the min stack top element, it should always point to the minimum element presented at any point of time.
And what if all are -1? In that case, what would happen?
I can share my implementation. I exactly had it.
Yeah. Now I think I got your solution.
You guys interested?
Thank you.
Please go ahead. Yeah, I think you can share your solution, please.
Yeah, sure. I'll stop sharing.
Give me 1 second. Can you guys see my screen?
Yes.
Yeah, so exactly this is my point. If you push any element, you check that your mini stack element, if it's lesser than the top element in the mini stack, then only you push it. And anyways, you are pushing it in your main stack. And same you are doing with the pop. So if your element is actually lesser than the all available elements, then only you push it in your main stack. That's the main point here.
Yeah, just one question I think, and probably that also we can solve, is what if all element are same,
Exactly. If your all elements are same, then okay, I just go with the easier implementation. So for if they are equal, then I'm still pushing it in the mini stack, but we can rework on this logic also.
Yeah, exactly. Okay.
Yeah, I agree. So this was just my quick implementation, but definitely the duplicates can be handled in a better way.
Yeah, maybe we can put with the stack value count also, or any sort of implementation, right? Okay. Is everyone clear about this?
Yes.
Looks like it was a similar approach rather than using an array. It was like in two stacks and maintaining the same level.
Mm-hmm. Yeah, I think so even though in suppose C we don't have stack, it's good to, you know, if you are doing whiteboarding, it's good to have use stack as implementation, you know.
Mm-hmm. Yeah.
So so that way you can still explain the concept with the less memory. Yeah. Okay.
Okay, Rishabh, you want to go with the next question?
Yeah, sure. I'll just share. I'll just move on. So, shall we move to the next question now?
Yes.
Yeah, okay, thank you. So the next question, like we are picking is like baseball game, and yeah, just will here also again we just take some few minutes to just go through the question once. Yeah, so can like shall we discuss start discussing the question?
Yes.
Yes.
Yeah. So basically, what the question is saying that we are we have a baseball game pointer recorder. We are recording the points of the game, and it has the following four types of as an like input, and on which we are basically have to analyze it and give the output. And there are four, you know, like out of four types, following types, we have one operation and three ways where we can store the score of the game basically. And the first is the integer input, like whatever the integer value we are getting at the input, like 5 4 3, the value of the point will be same as the input integer. Okay, and the second is plus. And what plus is ki whatever the input we are getting, and if it is valid, so just we have to take the last two valid input just before the when encountered plus in the we have to take the last two valid input to sum them, and plus will be output of the sum of that two last valid input basically. Okay, and third is d is also like giving output some output value, and it's also help us to store the score. And what it says ki whatever the last valid input will be there, we have to double that, and the d will store the doubled value of the last valid input. And there is one operation C we are doing where whatever the last before C, whatever the valid input is there, it will make it invalid, and we have to remove that basically. We don't have to count that input. So that is the four following type and the input will be in the string form, that was saying. And at last what we have to return is the sum of the all the valid input in the complete array. After like doing all the, you know, following operations, whatever we have the valid input in the array, we have to give the output of that, sum of that, sorry, as an output. Yeah, is just we'll take one example. Like here we have 5 first as an input. Yeah. Now I'm till now, am I clear with the explanation?
Yes.
Yeah, thank you.
There's still some
So
network issue.
here
though,
just
yeah, this is good.
yeah. So what I'm saying is, we'll take this example. Okay, 5 to first it is 5. Okay, so it is an in the string. Obviously, like I'm just considering that the integer value we are going to convert the string into the integer. So here I'm just, for example, if I'm taking valid, if I take just a valid input here, 1. Okay, and so first we are getting 5 here. So the first input will be 5. Okay, and yeah, and it is valid. So we'll store the value as 5 only here, and then we are getting 2 as an input. Okay, and so we'll store here 2 also as an input, and then we are getting C in the array. So what we'll do, ki whatever what C says is ki whatever the last valid input, we have to make it invalid. So 2 will become invalid and we have to delete. Okay, and then we encounter D in the input array. So basically what these do is ki whatever the last valid input is there, we have to double that data and we have to store it. So we can see that in the valid input array here on the right side, we have the 5 as the last valid input data. So we'll double that and we'll store 10 in place of D. Okay, and at last there is a plus sign. So the plus says ki whatever the last 2 valid input in the array, we have to sum them and we have to store that value. So here, yeah, I will be able to, yeah. So what the plus says is ki here we have to store the sum of the last 2 valid input data. So it will be 10 plus 5, it will be 15. Okay, so that's the now we have gone through the complete input array, and this is what we have got. So at last we have to return the sum of whatever elements we are having in this array. So if the sum will be basically 30. That's what is the output here we are getting. Yeah. So in here, if anyone would like to share their approach or any ideas for this.
Yes, for this question, I think we can use a stack to keep track of the transitions in state. So just keep a secondary stack which will store the state, and for example, when we encounter a plus, just pop out the previous 2 elements. Yeah, just pick the previous 2 elements and push their sum in the stack. If you encounter a double, just pick the top element and push the double of that in the stack. If you encounter a C, just pop the top value, and if you encounter a numeric score, directly push the integer version of it into that final stack. So at the end of after iterating over all the scores, you can just calculate the sum and return the final value.
So would you like to share code it, or would you like to share the code? Obviously there's a good approach. Or anyone would like to code?
So I have a question. So in the peak, we can only do like top element, right? We can't go the next of the top.
A Python, you can do -1, -2. So it gives you reverse indexing as well. So in Java, even if you do -1, -2, and you again push it, it's a constant time operation. So it's not timing.
Or else I think you can take a top variable. So top and top -1 will give you the two peak elements.
Yeah, I think so.
Yep. Yes.
So what Krunal is suggesting, I implemented the same way. I can share the code.
Mhm. So Rishabh, you want to stop sharing?
Yeah, sure.
So, are you able to see my screen?
Yes, yes.
Yes.
So, I take on
Can you
primary.
please increase your font size?
Yeah.
Yeah, thank you.
Okay. I just taken one stack, primary stock stack, and for each element of the string, I'm just checking first, is it plus or it is C or it is D or it will be integer. So if it is plus, then I will just pop up the first element on the stack. Then I will take the top element as a pick because I don't need to pop there. I will add those elements and I will push that again to the stack. So that will be the scenario when we are getting the plus sign and we need to add the previous two elements and need to push the third element, next element to the stack. Now in case of C, we can just need to pop from the stack, and in case of B, we need to double up the last element. So I will just pick the last element and we'll just multiply by 2. And if it is I think last one is the integer. If it is integer, I will just add in the stack, and finally I will do the iterate over the stack and just return the sum.
Are we not missing a case where if it is not an invalid character?
Yeah, I also had the same question. Like,
Yes, I can do that check, but yeah, because I in this exam is in this question there is given that all will be the valid, so I haven't added that check. Otherwise, I can add that check. Instead of directly taking the else and considering that it is integer, I can check that if it is something else, just ignore that.
Yeah, you're right. Actually, they said like it was always an integer or one.
Yeah, it was mentioned. Yeah, it mentioned that it was always be these things somewhere. So I haven't considered that it will be something else.
yeah, okay, only valid inputs. Got it.
Yeah, yeah.
So can we avoid that while loop at the end? Is there a way we can avoid the while loop going through the stack?
Yeah.
Yes.
Okay. Yeah, I think we can keep the track of score simultaneously while iterating through the input array. So that might
Ayush,
while
you
loop, I
also have a
guess.
network issue, I think. Both of you have the network issue.
Yes, so I think before you do any push, just keep a integer value which will hold a sum, and that will only, and you can just update the sum. Only when you cancel, just make sure to subtract the value from that into variable, and then at the end you don't need that while loop. You can directly return that variable.
Yes, it will work that. Yeah. Yeah, we can avoid this while loop means we at the time of push only we can just add that in the sum, and while doing the
Yeah.
pop we can just remove that from the sum.
Yeah. I think.
You might need to careful when it overflow, because if you keep it on the stack, it might not be overflow, right? But when you keep the sum, I think it might.
So the size of input is between 1 to 1000.
Maybe just keep the bigger, like the long. right?
Yeah.
Keep the sum to be long so we don't have that problem.
Yeah.
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 Yeah, integer out of bound can be another issue, but I think with the condition what they have, I think it will be should be fine, I guess.
If the size of input is 1000, some could go beyond, right? So still there is an overflow.
Yeah, yeah.
Yeah, I think what Leon is telling, if you're doing in the upper for loop, you would be doing add or remove operations. So when you do remove, it will bring it back to normal.
If you
So at
no,
line
are we
12.
saying, Asim, are you saying like there won't be overflow or?
No, I'm agreeing with that. If we are
Yeah,
doing in within 6 line within in the upper for loop, then there are less chances of overflow. Like what right now, if we're doing it 9, there could be chances of overflow.
I think as long as you are storing it in an integer, there is always a chance of overflow.
Okay.
Right?
I mean integer out of bound, that is also there, right? Other than stack overflow.
What's the size of
Stack
integer
overflow
in
is like
Java?
stack overflow is like number of input elements. If the number of input elements goes beyond certain limit, you would have that stack overflow, right? And here he
Here
didn't
the
mention.
here the max input element is given as 1000, means
Number of elements given.
size of the input list is 1000. So
Yeah, and they also
Size of the
said
input list is 1000, so there won't be
and
stack overflow. But
yeah,
even
the
integer overflow is highly improbable because it's a baseball game, and unless you have like 5,000 home runs per, not 5,000, like 20,000 home runs per round,
Yeah,
you
that's
won't
another
have it.
good point.
That's a very good point.
Yeah, but at the end it's like some automated code, right, which is running for the scoring. So it can run into some loop or something.
Yeah.
So any other question on this code, or I can stop sharing?
I think this is good, yeah.
Thank you for sharing, and yeah, so I'll just yeah, anyone else like would like share?
Yeah, I think
Or so shall we proceed to the solution, like obviously like as like sir has told, obviously it's a similar we have like different conditions here, and also like two conditions they need to be checked, one valid input and that we have to that is not asked in the question. So yeah. So here I have done is key first I am just checking the size here. If it is less than or equal to 0, I'll just return 0 because that's not a valid input size of the array here as per the question. And I'm just running the loop here, and I'm just checking again if else the similar manner, and I'm just storing in the top of it. Like if it is D, whatever the top I'm having, I'll just double it and I'll store it in the stack. And if it is plus, then I'll check for the last like two valid input, top and top minus one, obviously, and I'll just store the sum same manner. In else part, what after this three operation, like in else part, what I'm saying checking is if there is a negative input. Okay, like in example 2, we have a negative input. Okay, and so what I'm doing is first I'll just take the like integer value of that, and I'll, if it can be like multiple, it's -2, it can be -20 also, it can be multiple, like double multiple digit number also. So I'm just checking here that multiple digit input, and then I'm converting it to the integer and I'm storing it, and if it is negative, I'll just add the minus with that number and I'll store in the stack. And yeah, and then finally I'm just taking the sum of the complete out of stack and we are adding. And obviously here time complexity is like n, linear time, and space complexity is also n, because I'm using a stack of size, input array size basically. So yeah. So
Cool.
anyone has like to share any course point here?
Yeah, I think this is the same solution, right? I think it's the same.
Yeah.
Got
Same
it.
solution. Yeah.
But there is a while loop in the else. I think it's, as you said, like this is for the digits. So in C, I think maybe in Java and all also internally the function does the same thing, but there is a while loop which tries to navigate or through all the digit and get that. Yeah, I think that's fine.
Yeah. So, but yeah, just this is a while loop just to check that multiple digit input here.
Yeah. Okay. Yeah. Cool.
Yeah. So this shall we move to next, or like is there anyone who would like to add any point or share their code?
I think we can move to the next.
Yeah. So from now onwards, like Ayush will be taking care of. So handing over to Ayush.
Yeah. Thank you, Rishav. So I'll be carrying on the session from now. So I think I'll be covering two to three questions as the time permits. So first question which I'll be taking is next greater element. So till now, whatever questions we have seen were like typical stack implementations. Correct. Like if you use stack, you can solve the question. So now I'll see a question.
Can you show the question, Ayush? Like, what, can you share like what is the question?
Yeah, just a second. I want to share some points on stack first.
Okay, sure.
Then I'll show this. Yeah. So now we'll see a question which uses stack to actually implement the code in a better time complexity. So actually there are 4 types of question here, which take similar approach. There's one next greater to right. There's one next greater to left, and one is next smaller to right, and one is next smaller to left. So all these 4 questions take the similar approach actually. So and these are the basics for stack questions actually. So if we get these questions, I think that if we try to solve much harder questions, and they can be solved using stacks, and the logic might get much simpler if we understand these 4. So I'll be picking one of the questions and explaining those. So I'm picking the next greater to right. Okay. So the question is there in lead code actually. So is my screen visible properly? Yeah. One second.
With the question, please.
Yeah, sure. So yeah, is my screen visible? Increase the font actually. Is it okay now?
Yes, it's okay. Yeah.
Yeah, just go through the question once, then I'll talk about the question and approach. Yeah. Is the question clear? I'll explain the question. Should I wait some for more time?
Yeah, if you can explain with one example, like.
Yeah, sure. So I'll explain the wider view of the question first. Then we'll come. As you can see, there are two arrays given here, nums1 and nums2. So what basically the question wants us to do is, it wants us to return the next greater element. The array which it's considering is nums2. So we want to find the next greater element in nums2, and nums1 is the array for those element for which we have to find. As you can see, 1 is the number and we have to find the next greater element. So next greater is 4. Similarly for 3, the next greater is again 4. But for 4, there's no next greater element to the right. So that means we'll return -1 for that. And similarly for 2, there's no greater number to the right. So we'll return -1 for that. But this was the larger point of view of the question. But what LeetCode wants us to do here is only give the output for these three particular ones. And the question is made much simpler because it says us that there are no duplicate elements in the array. So that's basically, it's a unique array. So yeah, is the question clear a bit?
Yes. Right.
Okay, great. So so anyone have any approach or something, some points you want to share regarding the question? Okay, that's fine. I'll carry on with the approach. So okay. So basically this question can be solved in multiple ways. So firstly, I'll take the brute force approach. So brute force approach is simply I'll get the next greater element for actually, yeah, 1 second. Yeah, is the screen visible?
Yes.
So yeah, for nums2, what I'll do, I'll make a next greater element. I'll make an array in which I'll put the next greater element. So what I can do is I can iterate through the loop again and again. For example, if I'm at index 1, I'll iterate through along the loop, and until I get a next greater element, I'll keep on iterating. So once I get 3, I'll stop. Then I'll move to 3. Then I again start iterating from 3 onwards until I get the next greater element. So when I get 4, I'll stop. Again for 4, I'll iterate through the loop. So I didn't found anything, so I'll return -1. Similarly for 2, I'll iterate and I didn't found anything, I'll return -1. So this can be the brute force approach actually, whereas there is one for loop and there is another dependent for loop. So that might give us the answer actually. But again, that's an that's a O(n) square implementation. So we can use stack here to implement this question in much simpler and in much less time complex way. Okay, so anyone has to share something, they can try.
That's good.
It's good. Okay, fine. So what I'm doing here, I'm taking a stack here. Okay, so what I am doing that I'll iterate through the nums2 array, and if the element is the first element, I'll simply push it to the stack. Then I'll move to the next element and I'll check that if that element is greater than the top or not. If it's greater than top, then I'll simply pop out that element and return return the max that larger value in a dictionary. I'm using a dictionary to store the respective greater element actually. So I'll pop out that element, and the next greater element will be 3 for that. And at the same time, I'll also append 3 here. Then I'll move again. I'll move forward into the array. Now I got 4. I'll again check that 4 with the top of the stack. So now it's again greater than the top of the stack. So I'll again pop out 3. And at the same time, I'll push in 4 for that. So, and now I'll again move into the stack, into the input array actually, and I'll take 2. I'll compare 2. 2 is smaller than. Then again, okay, one second. I'll push 2 into the stack again. Now I've come to the end of the list actually. So my list is completed. The iteration is completed. Now what I'll do, I'll run a loop across the stack, and whichever elements are there in stack, I'll simply pop out them and assign them -1 because there will be no greater element for them to the right, because as they are in the stack, that means we haven't found any greater element to the right. So that means we have to return -1 for them. Correct.
Yeah, but 2 will come first. I mean, that's fine in the list, but I think 2
Yeah.
come out.
Yeah, two will come first.
Okay.
Correct.
Yeah.
Correct. So this is we got the respective next greater element for each and every element in nums2. Now what the question wants us to do is just the question just wants the next greater for these 3 elements. So I'll simply run a loop for nums1, and I'll make a result array. And for 4, I'll check it's -1. I'll push in -1. For 1, it's 3. I'll push in 3. And for 2, it's -1. I'll push it -1 and return this.
Can you please repeat the first part? How did we get that?
This dictionary?
Yeah.
Okay, yeah. What we did actually, we made a stack. We made a stack, and we iterated through nums1 array. And we kept pushing in the elements until and unless we got a greater element at the top. We got an element which is greater than the top of the stack. So I pushed in 1. I pushed in 1. Then I got 3. I'll compare that 3 with the top of the stack. So top of the stack is lesser than 3. So that means I've got the greater value here, which is 3. So whatever the elements are, so what I'm saying that 3 is greater than 1, and 1 is the element which was previous to 3. So I've got the just next greater than element. So I'll simply pop this out, and for 1 I have the answer 3.
So is this a next greater to left or right? Because we are
right.
finding a greater to like, for example,
Right.
1 and 3, right? 3 is right of 1, right?
Yeah. It's next greater to right.
No. Next greater to right. Okay. So
And
as
at the
we
same
traverse,
time,
as we traverse through the array, so whatever element we find, what is the greater after that? That's what we are trying to find.
Yeah. Just greater, just next greater.
Okay. So we found 3, which is greater to 1, basically now.
Yeah, that's why. And 1 was the top of the stack. So I'm saying if there was 1 0 here, so there would have been 1 0 here also in the stack, correct? So we would have compared the top of the stack, popped that, and because it's less than 3, we would have popped that. But again, at the same time, we will run a loop for popping out actually. So we'll pop out 1. Then again, the top is 3. Sorry, the top is 0. We'll check that if 0 is also less than 3 or not. If it is less than 3, then we will pop that also out. So now 0 is also popped out, and for 0 it's 3. But again, the point here is just the next element. So for 0, the next element is 1. So in this case, 1 would have been the answer only for 0.
Okay.
I'll take another example actually. That will make the approach more clear.
Yeah, I think we are kind of finding the next element just next to it or whatever we need. So I think maybe if there are elements which are lesser than, like multiple elements lesser than the previous element.
So it's like, okay, if there's 1 8, there's 1 4, there's 1 6, and there's 1 7, and another is 1, and 1 is 9.
What is the
So we'll try this up. Yeah, sure. It's 496.
Can you write on the top so that anyone can refer? Just in case.
So we'll take this example 8, 4, 6, 7, 1, and 9. So the approach will be similar only kind of. I'll make a stack. I'll push in 8 here. So now I'll move to 4. I'll check if 4 is greater than 8 or not. It's not greater than 8, so I'll push in again 4. Now I'll go to 6. I'll check that 6 is, my top is at 4 now. So I'll check the 6 with the top. You can see that 6 is greater than 4. So I'll pop this out, and for 4, I'll give the value 6. Now the top has changed to 8. At the same time, in the loop, I'll check if now what current top is. I'll check that with 6. So 8 is less than 8 is greater than 6. So it will still remain in the stack only. And after the loop, the 6 will also be appended here, pushed into the stack. Now we'll come to 7. Then 7 will be checked to the top of the stack. Top of the stack is 6, and 7 is greater than 6. So we'll pop this out. For 6, the answer will be 7. And now the top is 8. I'll check 7 and 8. 8 is still greater than 7, so we won't pop that out. And similarly, 7 will also be pushed into the stack. Now I'll come to 1. I'll check 1 is greater than 7 or not. It's not, so I'll push it into the stack. Now I came to 9. So 9 is greater than 1. So yeah, I'll pop this out. And for 1, I'll write 9. And then now the top is 7. I'll pop 7 also out. And for 7, I'll write 9. And now the top is 8. 8 is also less than 9. So I'll also pop 8 out. And for 8, I'll write 9. Now I'll push into 9 again. Push in 9 in the stack. Now my list is completed. At the end, what I'll do, I'll run another loop just for this stack if there's any element or there or not in the stack. So whatever elements are there in the stack, that means there is no element greater to them in the input array. So for those, I'll simply return -1. So I'll check the top. The top is not -1, so I'll pop out that element, and for 9, I'll assign -1. And my stack is empty, and here I have the answer for the next iter element. So this is the approach using stack. I think we can solve this question in linear time.
Thank you.
Yeah. So does this make sense now, or should I take one more example or discuss more?
Yeah. So just one optimization I would suggest is so your dictionary is containing all the states, right, which are not asked in the question as well. So for example, 4, 1, and 2 are the only numbers we want to find the result for, And in the example you provided, you will hold 3 as well. So I would just recommend making a set of the input, which is nums1, and only add the element to the dictionary if it is in nums1. So that, if there are just 3 elements that we care about and the nums2 array contains a million numbers, you don't end up exploding the dictionary with a million.
So you will be using that in operation in Python or whatever it is.
Yes, or just contains in Java, right?
So I think that's linear time operation only, that in operation and contains. I think so.
Not in. So in for a set is constant time. In for a list is
okay.
Yes.
Yeah, I think the smaller array goes to a set. That's what the suggestion is, right? So that we can check like what is there in the set and then take a call to add it in the dictionary or not.
Yes.
Okay. Yeah.
You need to create a dictionary anyway, right? So initially you just create a dictionary out of array 1. So array 1 have only 3 elements. You create,
I think
the value can be like
yes,
1 or whatever, right?
Then I was also thinking the same thing. But the problem there could be like, what is the default value do you keep? Like, is the value? Can you choose a value or a corresponding value, right?
Yeah, you can choose -1, right?
But -1 can be also part of the array, right? Like the main array. So that is where like it can topple, right? Like the nums2 can have -1 also.
It can be anything, yeah.
I said -1 because our default return index is -1, right? In case we don't have the...
Yeah, I think that's also a good point.
Yes.
And we just end up overwriting it, actually. Yeah, I think that will...
So I think that should work.
We don't really worry about like what is in there. So we have a default value and then we just overwrite it with the greater element if it's there. Yeah, I think that makes sense. Yeah. So we just create a dictionary of the smaller array, size smaller array.
Yes, and each value will be set to -1 by default. If you find a greater element, we will just override that -1 with that.
Yeah, that's a good.
Yeah. One question. Why do you say a smaller array? Why not always num1 has to go in a dictionary?
Actually, smaller. I think most of the time that nums1 will be a subset of nums2. So
I think that's given in the question. That nums1 is a subset of nums2. Yeah, I think it will be always nums1, I guess.
It will be always nums1. So when you come to the code, so what I'm thinking is you always create a dictionary from nums1 because anyway, that's what the numbers you are looking for the next character. And all of those values, like key would be 4, 1, and 2. Values would be -1 for all initially. Then you go from nums2 array 1 by 1 and do the same logic for the stack. And as far as we find the value, we will append or update, override the nums1 k value dictionary, kv dictionary.
Yes.
So by default, if we don't find any greater, they will have a -1. And if we find any greater, then it would be overridden. And in the end, we will have the answer there.
Yes. I mean, nums1 can be same as nums2 as well. I think.
After it can be same or subset. Yeah. So actually, I wanted to explain the wider point of the question that you just need to get the next greater element. But yeah, for the question, if it requires only nums1, yeah, we should go for nums1 only. That might be a much time space saving approach. Time will be, I think, same only, but space.
So initially, if we know if num1 is smaller than num2, is there any value of knowing this? Can we use this information somewhere? Nums1 is smaller than nums2, or nums2 is smaller than nums1. Do we have a? Is there any good value in knowing this information? Can we use this information somewhere?
No, actually. If the question doesn't suggest that nums1 is greater, nums1 is smaller than nums2, then I think we'll have to check that whichever length is greater. So we'll run the next iterator for that one, I guess, in that case. Because if the question says that either nums1 is subset of num2 or nums2 is subset of nums1, so depending on that, we will have to run the loop for that particular array. But overall, I don't think that greater or less, it doesn't matter. After all, you only have to take for the better approach, you only have to take the elements of the smaller one only. Yeah.
So what happens? I think there was this little deviation. Like in the question, it says no duplicates, right? So
Yeah.
can there be a variation of this question which have a duplicates, and then how do we like handle it? Like in this example, 8, 4, 6, 7, right? Suppose 8 and 9 is unique, and all the numbers are 4 in between or 1. Will this approach not work in that case, or we have to do some tweak in the code, like?
I think we have to ask the interviewer that if the value is equal, so should we return? No. It's clearly mentioned that we should return only next greater. So for equal also, I think we'll keep on appending to the stack. So if it's 8, 8, 8 completely, so I think the answer will be -1 for all. If there is 8, 8, 8, 8, 8, 8, 8, then I think that the answer should be -1 for all, because there's no greater. The question doesn't mention equal to also, but yeah, we can ask the interviewer that are you looking for equal also? In that case, I think.
Yeah, I think there are good variations of this question. So
Yeah, there are actually. This is next iterator 1 only. I think there is next iterator 2 and 3 also.
Oh, okay.
I just have one doubt.
Are you thinking of duplicate in a nums1 or nums2?
Whichever is the subset of which one. So the question here says that nums1 is a subset of nums2. So I think both can have duplicates.
It may not, relevant. I mean, look at the num2, right? Let's say you have a duplicate, and then the duplicate in 2 different positions. And how do you know which one is for which? Right. So let's say, suppose you have 1, 8, at the beginning, and then 1, 8 is, in the middle, right? Now you need to find the greater one, then how you determine, which one's for which.
Yeah, that might be tricky. Yeah, I think so. But yeah, that might be the question. Yeah, we have to clarify that from interview. So yeah, if by assumption, I think we can go whichever is the first 8, we can consider that, but we cannot just assume. We have to go through the question, I think so, in that case, or ask the interviewer that what you are looking for.
So I believe
I didn't get it. I mean, can you give one example, Leon? Like, what is the example array, input array, and then how to visualize that?
Yeah, Leon.
Let's see. I don't have I cannot share my screen. Yeah, but I can tell you the array input, and can you type it?
Sure.
So yeah, just say 8, 8, 1, 9, and then 8 again, and 10. Right. So we have duplicate 8 there.
Yeah.
So now you have one, the result is 9, the other one result is 10. This is a small example. You need to clarify with the interviewer, see which one should return, because repeat, it might not be consecutively next to one another.
Exactly. Yeah, I think this makes sense. I mean, I can visualize
Yeah,
this
it
now.
can be tricky. Yeah.
Yeah, and also the
Which need to
dictionary.
consider.
Since we are using dictionary, then also we have to see, because
Exactly.
it will just have
It will override otherwise.
Yeah, so we have to consider that as well. I think the
So
same approach will work based on the question, but which one you want to take as a higher number for the first occurrence of the key or the last occurrence? Yeah.
Yeah, that's one. We will have to clarify from the interview that point. But yeah, actually, that's a good point. Yeah.
So if the interviewer says that keep the first value, first greater one. So let's suppose in the 8, the next greater is 9, and for the same 8, next greater is 10. So there are 2. So we can ask interviewer that either we should choose the first one or the last one. So if we choose the first one, then we can ignore all the duplicates whenever we see in the num1 hash map.
Yeah,
And
I
if
think it's a dictionary, so you can keep on overwriting, because we are putting the default as -1 as a value. So I think we can compare the result and
the by default value is -1. So we know that we haven't seen this number. We can update it.
Yeah.
Correct. Yeah. That's really great approach. Yeah. If there is if the value is not -1, then that means we've already find the earlier one, and we'll simply update. But if the interviewer wants the later part of it, then whatever the answer is, we'll simply update. Correct?
Yes. That's a good variant.
Yep.
Yeah. So anyone would like to any other questions or points to discuss, so that we'll move on to the code.
Ayush, I had one more question. You mentioned about these 4 different patterns of this question, right? So is there any trick or like things to remember for solving this, or is the same thing works but with different different condition, left or right or greater or less than? So is there any suggestions on that side?
Yeah, I think actually these 2 questions, I think so. We have to start the loop from starting itself, from the starting, because the next greater we discussed, for the next smaller, what we'll do, we'll simply change for a greater than sign to less than sign. If the element is less than the top of the stack, that means we have find the next smaller element. So I think these 2 are similar. And these 2, I think so, we'll have to start from the end of the list, so that and starting from end of the list, we can apply the same approach.
Okay. Can you? I mean, I don't know how we are doing with the time, but maybe I can take a look at it. But I just wanted to see the one more example for this next one to the left, so that we start from the right. But I think yeah, maybe I can try it offline. Thanks.
Yeah. So anyone would like to?
I think the key observation is you always have, like somebody mentioned on the chat, right? You have a monotonic stack, but the thing is, if they say next greater, that means on the monotonic stack, you make it, the opposite. I mean, you make it in descending order, right? And if they say if next smaller in the monotonic stack, you make it opposite. I mean, on the ascending order. So it's always opposite to what the intention is.
And actually, next smaller ask us that which is the just next smaller element. Like for 8, the next smaller is 4. So I think the similar approach should work, but rather than comparing the greater than, that 4 is greater than 8, we'll compare 4 is less than 8 or not.
Yeah, but I'm talking about what, the property of the monotonic stack. It have to be in the opposite order. right? Because if you observe, let's say the next grader, then what on your stack? It in the opposite order, right? You go from like, on the top right, go from 9, 7, 1, right? In if you look at, from the top down, it's in ascending order.
Ascending order
of the value maintained on the stack.
Okay. You're saying, yeah, I think so. That might, yeah. I think 8 will be here. Yeah, all the greater, though we cannot say that it will be ascending only, because what if 1 was here and 7 was here? So it might have been 9, 1, 7. We cannot be sure of the order, I think so. But yeah, all the elements will be surely smaller. That we can be sure of. The ascending or descending, I don't think that the order will be ascending or descending somewhere, or will it be?
Yeah, I think it will be. I think, yeah, looks like it will be, because as soon as you find a bigger number, you just pop it out, right? So from the stack, the top of the stack.
Yeah. So yeah, maybe there might be descending order. Yeah. Good point actually. I think something to think about. Yeah. There might be ascending, descending. You're saying descending for next greater and ascending for smaller, right?
Right.
Yeah, I think so.
Yeah.
I think so. That might be the case. Yeah, good point actually. But yeah, talking about the approach, I think so. It should work. What I said actually. So you want me to discuss? We can try actually. Try it out, but.
Yeah, I think it's fine. Maybe we can
it's fine.
The time.
Okay.
On to the next one.
Sure. We'll go to the code now. Anyone would like to share the code if someone has some approach? Okay, that's fine. Okay, I'll share my approach. So yeah, what I've done, as I said, I've made a dictionary and a stack and a top variable. So first I'm iterating through nums2, and if the element which I'm inserting is the first element, I'll simply insert that thing, and I'll simply append that element. And again, then I'll come across 3. So I'll check 3 with the top of the stack. So in my top of the stack, it's 1. So I'll compare 3 with 1. So 3 is greater than 1. So I'll pop 1 out, and I'll assign 1 to 3, 3 to 1 actually, and I'll decrease the top variable. So and at the same time, I'll also append 3 into the stack. And I'll keep doing that. I'll in I now it's 4, so it will compare 3 and 4, and 4 is greater. So for 3, the value 4 will be stored, and 3 will be popped out, and 4 will be again appended to the stack. And next 2 will come, but 2 is smaller than 4, top of the stack, which is 4. So 2 will also be inserted. So currently 4 and 2 both are there in the stack. So nums2 is iterated. Now I'll come to the iteration of the stack. So in stack, I'll see I'll pop out the elements. So first 2 will be popped out, and -1 will be assigned, and 4 will be popped out, and then -1 will be assigned, because there was no greater element for those elements. And at last, I'll make a result array by assigning the whatever value I required for nums1. I'll iterate I'll run through the nums1, and for that I'll append into the result, and at last return that. So yeah. So is the code clear, or should I explain it again with another example?
Good.
Okay, great then. Okay, so anyone has any doubts or any other understanding required, or any other points to be shared? So yeah, we can discuss. Okay, fine then, fine. Should I move to the next question, or?
Yeah, let's move to the next question.
Okay, so yeah, my next question will be again a typical stack implementation question. Decode string, question number 394 from lead code. So just go through the question once. Okay. So yeah, is the question clear, or should I wait for more time?
Does it have parentheses?
No, only square brackets. Only square, inside the square brackets only.
Can we go to the next example? Like it can be nested as well, right?
Examples. I go through the examples one. Yeah, examples are key.
Can be nested as well. Okay.
Yeah. Actually, key. Yeah. You can see there are various variations. There's one here also. There's one, two, three are the variations of the question. Example.
Yeah, I think the question is clear.
Question. Okay. Fine. So yeah, anyone would like to pitch in their approach, or would like to share some points, something? Please.
So one approach that comes to my mind is something like, so what we have to do is do here is we have to first decode the string which is innermost, which is the innermost bracket. So something like a recursive function which first decodes the inner string inside it, if there is any inner string, and then from the recursion we are coming back and solving the bigger string which is part of it.
Okay. Something like depth search. You're going to the depth until you're getting a closing bracket, right?
Right. Yeah. And yeah.
Yeah.
I also had the similar approach, but like in a loop.
Yeah. You can implement same thing in iteration or in recursion.
Because recursion internally will use stack only, right?
Yeah.
Exactly.
Every recursion can be solved by iteration because.
Yeah. Exactly. Yeah. Yeah. So yeah, that's why it's a stack problem. Yeah. So yeah, the approach is quite clear. Yeah. Anyone? So would you like to share your code or some approach or something, or anyone else would like to share something else? Okay, that's fine. Then I'll start.
Yeah.
Okay.
So sorry, I can.
Yeah. Please.
I think you need to keep two stacks here. One for the current running string that you have, and another one will be the number of iterations that you need to repeat this string for. So when you encounter an open bracket, you just start pushing the characters to the character stack. And then when you encounter a closing bracket, you just pop off the topmost string and repeat it from the indexes stack. That times. I'm not sure if two stacks are definitely required, but yeah.
I think so. Yeah, it can be done using two stacks. Yeah, and while popping out the character at the same time, you can pop out the number also.
Yes.
And I think you can multiply or expand that thing that many times, and then after that, I think you'll have to store back to the stack again, right? Or
yes.
Yeah, that can be an approach. Yeah.
And at the end, you will have if the given string is valid, you will end up with an empty stack, and the last operation you can directly return.
Yeah, you'll end up with an empty stack and the whatever is the correct. Yeah, that might be approach. Yeah.
So if you have multiple digits, like instead of 3 in example 1, we have like 334, suppose, right? So we keep on going until we find other than numeric in the string, and then we put that as a whole in the stack, right? 334, not like 334. That doesn't make a sense, I guess, right?
I think if it's a single number, then you push it entirely in the number stack.
Okay. I mean, what I was trying to understand is like stack is of
bracket 3, bracket 4, then you will push 3, then 3, then 4, because these are different state, right? Each bracket has a different state, which you will be repeating based on the outer bracket count. So,
right. One more thing, I don't think that after 3, there will be definitely a opening bracket, and after that opening bracket there will be definitely a character actually. So I think the pattern for a valid string, not for invalid, there can be invalid ones also. For a valid string, I think so. If there is an integer, there will be definitely one opening bracket, and after that there might be a character.
So you're saying that, I mean, as per this question in lead code, that is how it is, or because that could be another variation, right? Like 3
that can be variation like this
based
thing.
on the inputs they have used. Okay, got it.
Yeah. Just for a valid input in this part, but yeah, any input can be given, so we have to consider those. So one thing for that 334, one thing we can do is like I'll run a fast forward loop inside that if statement only of the digit, that unless and until we are getting a digit, just keep on running that thing, so that we'll collect that 334 together and then simply typecast it to int. That can be okay there. So yeah, okay, that's fine. So I'll share the approach once. So anyone have to say anything or share anything? So, or do I proceed? Shall I proceed?
Is the empty characters permitted?
Sorry, I didn't get you.
Is empty character permitted? So for example, you have instead of like 3 and then you have an empty character, right?
The empty character is like this.
Like no, like in example 1, I think what Leon is saying is that 3a, right? So a is, suppose a is not there, it's like just an opening bracket and the closing bracket. Is that right? Yeah.
Yeah, right. It could be.
Okay. I think it's a valid input, but I'm not sure about this, like what are the test cases they have here. But this is also a valid input, I believe.
Yeah, that should be a valid input actually. I'm also not sure actually for
no, they have written, right? The input string is always valid, the encoded string.
Yeah. Oh, okay. Yeah. That's what lead code provides that.
Yeah. So it won't be empty there, right?
Yeah. I think those could be variations of these questions. Yeah.
Okay. There can be many variations or buggy inputs, like
Yeah, because if that's the case, we might need to handle that case a little different, right? Because if we have two stack, one with the number and the other one with character, and we might need to repeat, like in this case repeat 3 empty string, which is still the same, empty string.
Yeah. Yeah, I think if there's an input like this, yeah, we have to take care of that. For empty string, 3 times empty string will again return an empty string, and I think it won't matter. And I think it won't matter.
And also, I was thinking like we can do this in one stack also. I mean, I think somebody suggested with a 2 stack, but I think we can keep on adding elements on the stack until we get the closing bracket, and we just have to make sure that it's whether it's a number or an alphabet or one of the opening or the closing bracket. I mean, for valid input.
You can make a stack of objects. Yeah, I considered the similar but in Python. Yeah.
I was thinking that we can make a stack of a string and then everything goes with a string, and then when we pop it out, like if it's a number, then we convert it to the integer, and then we do all the processing and push the result back.
Yeah, that might also be that used here.
Can we open a drawing board and using the stack, can we just see like if it is feasible?
Yeah, that's what I was
Can you clean this?
Yeah. Sure. So as the first input was, I think so. This was the first input, I guess. So what I did, I made a stack. We can make. I'm sharing a single stack approach actually. So I came across 3. I appended 3 here. If I come across an opening bracket, I'll also append an opening bracket. So then I got a string. I'll append that string also. These are all string only, all string. And then I got a closing bracket actually. So in that case, what I'll do, I'll pop the character out, and then I'll pop the opening bracket also out, and after opening bracket, I'll also pop the integer out. So integer will be 3, and this will be a, and string is a. So I'll simply multiply these, and the output will be triple A, and it will be stored back into the stack. So what I'm basically doing is I'm evaluating individual parts of an output. You can like divide this into 2 individual ones, and at the end you can even simply add those things.
So what then after that, like from 2 again?
From 2, once I get 2, I'll append 2, then again an opening bracket, then BC. Now I got a closing bracket, so I'll pop out BC, store it. Then I'll see if there's a there should be a if there's a opening bracket, I'll pop that thing out again. And if there's there should be definitely an integer after that opening bracket, so I'll pop that out also. So now 2 BC is there, so this will be okay. Sorry, BC, and it will be pushed back into the stack like this. So now we have again reached to the end of the input. So what I'll do at the end, I'll make a result, and I'll simply add all the whatever is there in my stack. I'll simply add and return that. So yeah, this was actually basic input. I'll explain also a complicated one, like a nested one. So yeah, was this approach clear for this input?
So in the stack, you will have BC as the top, and then you'll have triple A's below, right?
Yeah, yeah.
So when you're popping out, the first element will be BC, and then triple A.
Yeah,
But
yeah,
you're
yeah.
returning
We
here
take
as triple A and BC. So how that you're taking care?
we have to actually I'll what we say is like I'll pre-concatenate.
Okay.
It's like I first popped out BC, then whatever I popped out, I'll first concatenate that part.
Okay.
So in Python, actually, it's A plus B only. So
Yeah, I think in Java you can use string builder and like put it like as a prefix at the 0 position or something. Like there is some
Insert at the beginning. Yeah.
yeah,
Makes sense.
inserted beginning or something. Yeah.
Sure.
Or you just append it, insert at beginning. It may costly,
Yeah.
right? Append it to the end, and at the end just reverse it.
Yeah,
I don't think you can reverse it because this is string, right?
Yeah, you can't reverse it.
Oh yeah, that's a string. Wait, in this case you can reverse it, right?
You can reverse the string. That is also, I think you can reverse also, right?
No, it will be CB.
It will be CB, right?
Oh, okay, yeah.
Reverse the whole thing.
Right. Oh, yeah, right. yeah. That's a good point.
Yeah, actually, this was a simpler example. I'll take another example. I think so. Another example is okay. Sure. Can I clear this?
I think Ayush, we have less time, so should we go
Okay.
ahead?
Okay, that's
Unless
fine.
somebody have any questions.
Anyone has any other questions, or should I move to the approach, the code part?
So I have one question. So what if we need to evaluate the second part of the string first instead first one? Or we do not have that case at all? Yeah.
No, that's what we can have that if a nested input is there, like 3 into A into 2 into this. Inside this bracket, there's another bracket. If something like this input is there, then you'll first evaluate this, and you'll store this part into a stack. Then you'll pop this thing out and this thing out, and the complete into the stack.
Got it.
I'll share the approach that I think that might clear a bit. Okay. So is the screen visible, or should I increase the font? No, it's too large.
Yeah, that's fine. Yeah.
So this is my stack actually, alphas, and I'm running a loop into the input array, which is my S. So what I'm doing, if the input is digit, this I'll simply append it to the stack, and this portion is if there's a multiple digit input, like 33 or 44, something like that. So I'll evaluate those directly. It's like fast forward. Your I is at 0, then here itself it will go to 1 if the input is of 2 digit or 3 digit, and you'll append that thing into the stack. So it's Python, so everything is of you can append different objects also. So I've directly appended or pushed integer part. Okay, so again, if it's opening bracket, then I'll append that also. If it's a closing bracket, I'll discuss that later. Okay, if it's a character, then I'll append the whole string into the stack. Okay, this else part is for that. So now if the closing bracket is there, that means the evaluation part has come now. So what I'll do, I'll keep popping out from the stack unless and until I get a I get a opening bracket to the top, because that means that I have characters in the top. I'll keep popping that thing out, and I'll make a current string out of that, and then I'll again pop out the popped element now will be the opening bracket, and I'll pop the integer part, so that integer part is popped, and I'll just simply expand that thing that many times, and again append that thing back to the stack. So this bit, it's a bit tricky here, but if you'll see, first 3 was appended, then opening bracket was appended, and then A was appended. But once the closing bracket came, we first popped out A, then opening bracket came, so while loop got executed, and then that opening bracket was popped out, and then 3 was popped out, and then current string was updated to 3 times A. That means AAA, and AAA was again pushed back into the stack. So yeah, so this is how we evaluated that part. Then we came across 2. We again pushed 2 into the stack, then opening bracket also, then BC also, and again when we came across a closing bracket, we popped out BC, and we got a opening bracket, and we popped out that also. Then we popped out 2 and multiplied to BC 2 times. That means BC, and again added that to the stack, and then we went to the end of the input and stopped the execution for a while. And after that, whatever was there in the stack, we simply concatenated the whole thing and returned the result. So this was my one stack approach actually. So did I made my point here? So,
yes.
Yeah. Is it other explanation or doubts are there? You can share. We can discuss something.
So again, we are considering here, I think it's similar to previous question, like we are not considering like there can be a invalid input like that
yeah.
other than these characters, if something else is there or curly brace is there, that we are not considering.
Yeah, we are considering the comfort provided by the hit code here actually. Yeah.
Okay.
For a good code, yeah, we should actually consider all the cases. But
yeah, and I think this question, I mean any stack question with integer, it will have the similar issues what we discussed. I think somebody called out like the stack overflow or those kind of things.
Yeah. Like in the valid parenthesis question, which is a basic stack question, you need the stack empty at the end, right? For to be a valid input. Similarly, in all the stacks question, you need a stack empty at the end. If the stack is not empty, that means your input is invalid. But lead code says here that the input will always be valid one. So okay, in that case, I think we can.
Okay.
So yeah, any other thing anyone wants to share a bit of something, or you want other explanation something? If someone has other code, please do share. To stack approach, someone was saying if someone wants to share that. I think that time is also, yeah. We can discuss one more question if this is okay. This is done.
Yeah. Not sure.
So yeah, should I move forward then?
Yes.
Yeah. Okay. Thank you. So yeah, next question, which I'll be discussing, is a really good question actually. It's a typical stack problem, which is implementing n stacks using a single array. Okay. So go through this part once. Try to understand the question. Actually, we have to implement k stacks or n stacks, whatever number of stacks, using just a single array. So yeah, just go through. So yeah, is the question clear? Like, so anyone would like to share any approach or something for this question? It's a really good question, I think.
Yeah, I think I did this problem sometime back. So the way I solved it is, as we have to implement a multiple stacks within a single array, right?
Yeah.
So when we say multiple stack, that means there needs to be a multiple uh, tracking point. Tracking point in the sense like multiple tops of that stack. So whatever the input is given. So if there is n stack, then that means we have to keep track of top of every stack. That is one thing, and the other thing is that we have to take another array which will keep track of the element in the stack. So and the third point will be what is the third array will be there, which will be tracking the next available index where the element can go. If we are pushing and there is a space available, then where the next element will go. So we will have three different arrays. One will be keeping track of the top of the stack, and one will be keeping track of the index. What is the next available index where the element should go, and the third array will be for the data.
Yeah, can you share your screen and explain? I'll stop sharing. If it's okay, otherwise you can carry
on. Yeah, I can show it. Unless somebody has any other thoughts, I can show, like, I have the code which I haven't seen from long time, but I can just show it my approach.
So yeah, if anyone has any points, so they can pitch in here.
Yeah, I can share my screen otherwise.
Okay, I'll stop sharing.
Okay, can you see my screen?
Yeah.
Okay, yeah. Yeah, so this is the code I had, which I wrote sometime back. So as I was saying, like, we are keeping track of three things here. In order to keep track of multiple stacks, we have an array which is top of the stack, and then we have the data. What is the data in the stack in that array, basically, right? And we have a tracker which will keep track of, like, what is the next available index in that array. So how can I draw here? I just wanted to show.
I think I also have the similar approach. I think so.
Okay. Yeah, so I'll just give an overview of it quickly, and then maybe you can explain further. So what I had, and then
Yeah, sure.
then what I'm doing is that just to start with top of the stack, I'm initializing as we do in the regular stack problem. Like we have top of the stack being initialized as -1. So basically there is nothing as of now. So as in when we insert the element, so this will point the next top for that stack, a particular stack. And at the same point, the next index tracker is where we'll be keeping track of what is the next available index. So basically what I meant by this is, suppose we have an array of size 5. So what I'm doing here is that for the first one, I am having, what I'm saying is that for index 1, the next available index is 1, or it should be 0. I'm a little bit confused. So this is what I'm doing.
I think it should be 1.
Yeah. And for the last index, so it is of size 5, 0, 1, 2, 3, and then I put -1 here. So this is how my next available index tracker is, which will say that initially you will put your element at the first position, and then next available index will be 1, where you can put your element. So if you want to, for example, there are 3 stacks for an array which you want to implement. So you inserted first element at the 0th position. So the next available is 1, right? So if you want to add an element to stack 2, so that element will be going here actually. And if you want to insert an element again at stack 3, suppose at stack 3, then that element will be going here. This is an index tracker basically. Yeah, I'm not sure if this is making sense, but if anyone have any questions, we can discuss.
I have a couple of questions. First, why we need to have 2 array of the same size, right? The stack data and the next index tracker. Because I thought like we should minimize the space usage, right?
I think for this problem, it's not asking for minimizing the space for minimizing the space. Yeah, but definitely we can think in that direction. But the nature of the problem is then how do you keep track of? So one is the data part, and one is like where you will be adding your next element, right? So you need some kind of tracker, like which index you will be adding your next element or pushing your next element.
Yeah, we need the track. What if we pop out any element in between? Then we need the index of because okay. So I'll explain that.
Yeah. So I think let me draw, and then maybe hopefully that gives some more like.
Okay. Yeah. And my second question is like, how do you know which index will be available to store the data?
Yeah, so that is the piece which will be, so this particular array is for that, where you push your next element, and this the top is where you pop your element from. It will always keep track of for stack like 1 or like stack n. You go to that nth index from the top of the stack, and then pop that element from there. And whatever index this top of the stack gives you, you put it back in the next index tracker. That means that is the available position which where you can insert your next element.
Oh, okay. So it's like a free storage somewhere.
Yeah, exactly. I mean, it's all about like this problem is more about like tracking the index, like where you put your next element, or where you take the element out from. So basically, let me try explaining it with an example. Suppose I just took this example of 4 element of stack. So now what we are saying is in stack 1, let's try to add 2. Okay. So what I'm going to do is I will go to this next index tracker, which I have initialized like this 0, 1, 2, 3. And if it has reached to the last element, that means there is no place to, after that it's full. Basically my stack is full. That's why I have put -1 here, which is this condition at the end of this tracker. And initially when we say we have to push an element in stack 1, so this is the key piece, like we are trying to push an element to first stack. So the first stack, we get this position, the index tracker gives me that position, which is 0th position, and I push that element in the array. So this is my array actually, which is acting, which we have to annotate like acting as a multiple stack, but we have single array as an input. Okay.
Yeah.
And yeah, and then suppose we have 3 stack, S1, S2, and S3. So what I'm saying is in the input, it will tell me like where you want to push the element and what is the element. In general, we push, like when we push to a stack, we know that we just pass an element, but here we have to pass the which stack you want to push the element to. So,
yeah.
So here I am saying that in stack 1, I want to push 2. So if we see this flow, so I have a variable next available index, which is 0. So this is nothing but this element, which is default to set to 0. I'm not sure how we are doing with the time. So Bhavesh, can we?
I can if time allows, I think I can.
Is it okay to discuss further, like, or?
Yeah, we can discuss for some time. Yes,
Okay.
for let's say 10 minutes or so.
Okay, yeah, I think we should be done by then. Yeah, thanks. So what we are saying is that we are trying to add an element 2 in stack 1, right? And I have a variable next available index. So this tells me whether my stack is full or not. So right now the next available index is 0. So that is my key point actually. If you see here in the code, line 38, so the next available index is 0, which is my current index. So I just put this element to index 0. This is my index 0. Okay. So what I'm doing is I'm taking a temporary variable and getting that, because I have to deal with this current index all along when I'm pushing an element in the stack. So what I'm doing now is that I go to the index tracker and try to fetch its value, what is there in the current index. So which is nothing but actually I have started this with 1. I think I did,
yeah,
because this is the I plus 1 actually. I think this, please just pardon me, this starts from 1 actually, because that's where I get my next available index, because the next available index by default was 0. So
next
that,
I think next to next available, I think.
yeah, because this takes care of the default index, and then this should start from 1 and this should go to 2 actually. Sorry about that. So it should go to 4, because when it comes here, the next available index is this one actually, where you can, I mean, in this array, this will, last element will be the where we can put the next element. So what we are trying to do here is that current index is 0. I'm just talking about the first element. So the current index is 0. So at 0, we have 1 in this next available index. So I am resetting my 0 to 1 actually, saying that my next available index, which I can play with if somebody try to push an element again to 1 to first position. Okay. So I am updating my next available index, and at the same time, the top of the stack count, which is nothing but the stack count is 1. 1 or 0, so it can be anything. So the next index tracker for 0 will be -1. So what we are trying to say here is that top of the stack initially has -1, right? So what we are saying is that we are adding in the next index tracker, we are replacing this -1, this 1 by -1 actually. So what it is, I mean, this is a very key point, like to understand that this is tracking the previous position where which will become if you try to pop this element. So if you try to pop S1 from stack 1, 2, right? So its previous position was -1, which is the default value, which we are doing here. So that we are storing in the next index tracker. Is it making sense? Because this is very key point and it took some time for me to understand this.
Yeah, I think so. You're trying to say that once the element is set, then after that the next tracker will give the index of the previous element of that stack, correct?
Previous position, yes, previous position. Like for stack
position.
for stack 1, before inserting this element, the previous position was -1, right? The top of the stack was -1.
Yeah.
And as soon as I insert any element, which is initially set with -1, if I'm inserting any element, what we do is we increase our top, right? The position. So whatever is the current index is, that goes to top of the stack. So since I have added one element to stack 1, the top of that stack count become the current index because my top will be pointing here for this stack. This is my 0th position, and this becomes the top of my S1. And at the end, what I do is, I mean, this is the very this is like at that index I am tracking the data at that point. But the key point are these 4 statement actually. How do we, the next available index is very key here, so that it gives you the current index, and then you play all along with that current index, and you reset the tracker, like what is your last index which you processed, so that you can come back to it again. Is it making sense? Like I'm not sure if I am going too fast or.
It's making sense. So I think the next available index basically is the main important array. I think as you are saying, and it helps us for tracking 2 values. Like the
next available index is a variable, and the next index tracker is the
one. Next index tracker.
Keep track of like what was the last value, last index we were trying to serve.
How do you know the size of the current stack of this stack?
So size of the current stack is I mean, at max it can have the array size. Okay, so suppose there is a 4 element in your array, right? So at any point you can have 4 element maximum in whatever stacks you define, right? So for example, here I define, suppose I'm taking example of 3 stack. So the size, I am not sure if we can find from
the top. I think we can find the size of each stack.
How can we find from the top? Like it's an index, right?
Okay. Yeah. No. Yeah. We can't find the size, but the size will be dynamic, I think so in this case.
Let me go further just quickly for this example. Hopefully that will make sense. So I'm taking an example where I have to again add an element, suppose to stack 2, right? And in my current array, I just have one element, which is at position 2, right? And suppose I want to add 2 in stack 2. This is a key point. Like I want to add in stack 2, not in stack 1, 3, right? And using the same array, right? So again, if you go through this flow, my next available index is 1 because after inserting 2, I have reset this to 1, right? So that become my current index, and that is my playing point. Like that index become my playing index, where what I do is I go to next index of tracker, which is the current index. So current index is 1, right? So now we know that in the index tracker at one position we have 2 actually, right? That is the next available index. So again I reset my next available index to 2. So basically what I'm trying to say is that this is the next position where you can put your next element. And what you do again, like top of the stack for the stack count, again for 2, the stack count, current stack count, top of the stack is -1 only. So what I'm saying is that for this index, current index, again add -1. So again at this position I am adding -1. In the index tracker, I am again adding -1 to this position.
So one question here. So I mean, I think you are explaining the approach through code, but I think like it's harder for me to understand. I don't know about others, but probably like first you should explain like what the approach is, and then we can go into the code. I mean, you're going through the code and then explaining the approach, which is harder because
actually I thought it will be more easy to relate both of these. Otherwise, it will become more confusing. But still,
so
if it's
one,
okay,
my one question is that so what is the problem we are trying to solve? If we have n space and if we want to store k stacks, a simple approach is that we divide the total array into k slots, right? And then we know that what is the starting position of each slot because we can do math n by k, right? And then we just need to store the top of each of the slots because the top will vary. How much elements we have stored, the top will vary. So I think we need just one array for the top. We know the start of all the arrays because they are equally sized, right? This is one approach, and this is how we can store. But I think like I have not read it fully, but the problem it says is that now you have fixed the size of each stack, and probably your stacks might not need, like if you have initially k stacks, which is 5, but you end up only using 3 stacks, then you have already reserved the space for 2 more stacks which you didn't end up using. And I think this is the problem which you are trying to solve with this approach, right?
Exactly. I mean,
Yes.
you have put it in the
So now
right
let's
way.
go to how you are solving this approach, and then probably we should go to the code. I think that would be much easier to understand.
So if it's okay, can I share the approach?
Yeah, I think so just to add to your point, as I think you rightly mentioned that it's not a fixed size. Like if you are given a array of size 4 and then you have a stack of like n stack, like 3 stack, right? So you cannot just this is a dynamically sized stack, right? I mean, only the stack 1 can take all of your array, okay? And you may not have any space for stack 2 or stack 3. For like, I'm just giving an example, like you have a stack of you have n stack, which is of n is 3, and you have an array of size 4, okay? So you can push all your element to stack 1 itself, and you may not have any space for stack 2 and stack 3. So that is the problem we are trying to solve. I think you already said that, but just I wanted to clarify on that.
Yeah,
does that make sense?
Yeah, actually the point is for n stacks you need not to fix the size for all the stacks. Actually, once the array is full, that means all the stacks are full. It doesn't matter if there is 1 element, 0 element, 2, 4, 3, what number of elements are there
It's a
in each stack.
dynamic. Yeah, it's dynamic. You cannot just divide the stack, divide the array into n stack. So it is dynamically increasing the size of the stack. But yeah, I think Ayush, I'll let you go through with your approach, and then we can
try to complete as soon as possible.
I can share the code.
Time is running out. We are running out of time.
Okay, yeah, please go ahead.
Yeah, please. So yeah. So the approach is kind of similar, only what we just now explained. So what I'll do is here, I'll take for instance 3 stacks, okay, and one will be my top of stacks, which will be all -1, -1, -1, and another will be my data, which I'll initialize them to 0, 0, 0, 0, and I'm considering a size array of size 6, and one will be my next index, and that will be 1, 2, which I'll initialize to 1, 2, 3, 4, 5. I'll come to the points later. Okay. Okay. And one will be next available index will be, which will be 0. So these are the three. These are the variables which I'll be using. So this will be the top of the stack. This will be the data which I'll be storing, and this will be the next index, and this is the next available index. So what I'll do.
Ayush, can you just? I think whoever's saying like they needs to understand the question. So can you just take one example and then go through it before even jumping into?
I'll be taking an example. Just to say. So if I want to push in stack 0, if I want to push 1, so I'll push 1 here. Okay. So what the approach will be, I'll go to next available index. My next available index will tell me which index is available in the stack array. So it says me that it's at 0. So I'll go and assign here 1. And now what I'll do, I have to keep track of now which is my next available index, correct? This 1 here will point to the now next available index. It's like once you have set this one, you have 1 here in the next index, which will give you the value of the next available index, which is this, because this is the space, empty space now. So this will get updated to 1. And now the top of your stack was what? Will be what? Wherever you push the element, correct? So this was 0. So top of the stack will be changed to 0. And my next index, now this is the tricky part actually. Previously it was 1. And once the data is set as at that index, now the next index, what will do? It will give me the position of the previous element of that stack. So my stack 1's previous position was -1 because this is the first only. So next index will be nothing but -1 here. Correct. So yeah. So now if I want to push in stack 0, if I want to push 2, in stack 0, if I want to push 2, so what I'll do, I'll go to the next available index. See, the next available is 1. I'll go to that index. I'll push 2. And this time what I'll do now which is the next available index after setting, it is 2. So I'll update this 1 to 2. And now what I'll do, now the top of the stack 0 will be what? Now the top of the stack will be 1, because the stack 0's top is 1, correct?
Wait, how do you know the next available index is 2?
Yeah. Next
Okay,
available index. Yeah.
Yeah, no, I want to understand the approach. So in this approach, we are not going to waste any space. We are going to make, and so let's say we have to store 3 stacks in this case, right? So let's say now my first 3 inputs are inputs to different stack. That my first input is for the first stack, second input is for second stack, third input is for third stack.
Yeah.
So now, how would I know that how much space I should reserve for the first, second, and third stack? Is it like so we start with the first, second, and third index, and then once the elements keep on getting added, we will shift and move the elements? Are we shifting and moving the elements so that we can accommodate space for the first array?
No. The space concept is like once your array is empty, that means whichever element of whichever stack you want to push, you can push. But once your stack is full, so you can't push. That shifting, I don't think in this case you can do, because that will mess up the next available index and the next index part completely.
Maybe I can try to add something here. So as you said, like we have 5 elements, right? As in this example, and we have n stack, which is like 3, right? And as you gave the example, like in stack 1, you want to put some element 2, in stack 2, 3, and in stack 3, you put 4, right? So out of your 5 element in the array, all first 3 are filled with stack 1, stack 2, and stack 3 element. Now, if you want to put an element in stack 1 again, so that will go at your 4th position in the array.
Okay.
So it's not that you are shifting and keeping all that is the key point to understand in this problem, that you are not keeping all your elements together in the for one stack.
Okay, we are not keeping together.
Yeah, we are not keeping. Yeah, that is a very key point, and it took me some time to understand that.
And we are linking them. So through these arrays, we are linking them that now next element is over here. So
Exactly. Yeah, so that is very key point, because it takes some time, because it's a dynamically increasing stack within that space what is given to us, which is an array. And when you add a 4th element, which is in stack 1, so that goes as like 5, right? And then again you add an element in stack 1, which is like 6, right? And if you try to add an element again, so your array is already full, right?
Yeah.
So it will say that, okay, if you want to add any more element in any of the stack 1, 2, 3, you don't have any space to add. But the whole idea is that in the whole array, you can have your stack elements all like scattered within an array. It's not that you are keeping all your one stack element together, the second stack together.
Yeah.
So
and
in the next
because I had the same issue when I tried to go through this problem.
I want to say in the next index, initially you keep it -1 to indicate the stack already full, right? And now you keep, put -1 in there.
Because
and that -1 indicate like different meaning. Let's say, this is a previous.
Yeah, exactly. It's the previous. Yeah, once the element is set, because initially it was 0, correct? But now it is set to 1. So once the element is set, this is the use of the next index is completed. But we can use this as the for keeping track of the previous one.
But initially, what did -1 mean? The array already full.
Yeah,
right?
Before even going here, I just wanted to talk to like whoever was asking the question. Is the question clear? Like, I think there is some doubt. Okay. Yeah. Now we can discuss about this point. Yeah, thanks.
I have a visual explanation actually. Example, I think so. I just thought of it. Just visualize a bank and which having 3 counters, and people are standing in a line in all the 3 counters, and suddenly something happened and all the 3 lines got mixed up. But what will happen that I know who was standing behind me, and he knows who was standing behind him. So in that way, you can keep the track of the line actually. So I think those 3 lines were the 3 stacks, and everyone will know who was behind him.
Okay. Yeah, that's a good explanation. And now you will link them back through that data.
Yeah, but only difference is in this example, it's like first in, first out, right? But this is just to relate to that index thing. That is what I think Ayush was trying to say, right, Ayush?
Yeah, exactly.
Okay,
Yeah,
okay. But Leon has some questions, I guess.
Yeah, please.
Yeah, so, I already said my question.
Yeah, I mean, what you're trying to say is that if we are setting the previous top of the stack as -1, that means we are saying that stack is full. That's what you're saying, or empty?
Yeah, which I mean, it have 2 meaning, right? Initially, when it's -1, we indicate that okay, if it's -1, that means stack already full, right? But now, we update the next index, the value could be -1, in this example. And -1 here, as I understand, that means the previous element that's empty.
Yeah, I think this point is coming from my code, because that maybe confused you, because -1 is nothing but the stack is empty, right? But we were not checking for the next index array for stack to be full. We were checking next available index, I think, in my code. If I can.
Okay, so initially you have -1, you have 0, or you have 1, 2, 3, 4, and -1. That -1, what does it mean?
-1 means that you have reached the end of the stack now, actually.
Yeah, that means the stack already full, right?
Yeah. You won't reach at that last index unless and until all of your previous indices are full.
Okay,
you only reach
that's
at
the
that
meaning
last.
of it. Okay, but now we have -1 again, and that have different meaning.
Actually, -1 will get updated once that array is full. Actually, it's 0 here, na. Suppose if a value is set to 6, then this will get updated to the previous top. Actually, if the previous top was supposed to, then it will get updated to that. And the -1 will come to the next available index, which means that your stack is completely full now.
What I think is, initially when at the fifth position there is -1, that shortly shows that the stack is full. But when Ayush has put this -1 in the next index at the first position, it won't. After placing this, it won't come again there unless and until we pop the element. So I don't think it will make confusion like that.
I think that is what exactly the Leon question is, that now we are saying that -1 is nothing but like the stack is full, which was at the end of next index array, right? So there is a confusion between next index and next available index. That is the confusion. So so Leon, just to answer the question, I'm not sure if I can explain it, but whatever we are putting in the next index equal to -1. So next index is an array, and next available index is a class level variable, which is keeping track of the next available index, right?
Yeah, next available.
So there are two different things, actually. That's what is confusing.
Just I'll take one more push in the stack 1, element 3. So this will here 3 will come, and this will be updated to top. Now top of stack 1 was -1, right? So this will get updated to -1, and the next available index will be index 3. Okay, this I didn't change. This was previous top is 0. Yeah. So now this is my current stack. Now what if I called this operation pop from stack 0? So which element should be popped? Obviously, I think this 2 should be popped, correct? So 2 will be popped. So now what will happen is that this element should be popped. Now we know that the next available index is 0. But once this is popped, the next available index should change to this one, right? Because this will be empty now. So how we will keep track of that, actually? So what we will do, we'll simply change the next available index to the top of the stack, like whichever index we are emptying. So this was 0, top of the stack, we empty top of the stack. Now top of the stack will change to what was the previous one? Previous one was at index 0.
Ayush, I think the top of the stack will be 1 when you have already pushed 2. The top will be 1 that time.
No, I'm popping out 2. I'm popping out 2.
Popping out,
so,
yeah. So next level will come to 1 actually, not 0. Next level will come to 1.
Yeah, sorry. Yeah, my bad. Next available will become to 1, and the top of the stack will become to wherever its next index was pointing. Next index was 0, so next index will, top of the stack will become to 0, which is correct, right? Because 1 is at index 0 only. So this will get updated like this. And this next index, what will happen to next index is like whichever what was the previous value in the next available index will come here. So in the next available index, previous value was 3. So that's what. So now if a new element comes, it will go at position 1. Here it will come. And in this manner, the memory will never be wasted actually. So uh, the data will keep moving to the right, only move to the right unless and until all the left indices are full. If even one is empty, then it will first fill that and then move to the right. So so to answer Leon's question, so once by filling, once it comes to the last index, so when it comes to the last index now, so then it will change the next index to the previous top of the stack, and the next available index will change to -1, showing that your stack is full.
Yeah, so next available index will come to -1 only in one condition, when your data array will be full. Correct. Not
Yes.
before that.
Yes. Yeah. So I think yeah, just I could have explained more in much better way, but yeah. Is it making little sense? Some sense of?
Can you post your code? I might need to look at it later.
Yeah, I think Ayush, you can show the code now, and then we can take a look at it actually, and like it will be there in GitHub, right? So you can walk us through quickly with the code because we are over time anyway.
Yeah, sure. So I coded in Python actually. So if I want to push, I'll pass two operations. Okay, just ignore these. Mainly, I have two things: stack number and data. So firstly, I'll check if the next available index is -1 or not. If it's -1, that means the stack is full, so stack overflow. And now what will happen? This is the main code part actually. So it's a bit of a cycle. So first thing, when I was explaining, I said that once the data is to be inserted, I'll check which is the next available index, correct? Then I'll go to that index and store the data there. Okay, and then I'll once the data is stored, then I'll need which is the which is the next available index. So where I'll get that? I'll get that in the next index. So whatever value was there in the next index will go to the next available index. And once the value of the next index is updated, then it will now point to the previous top of the stack. So previous top of the stack was this, so it will get updated to previous top of the stack. Now previous top of the stack, what will happen? Previous top of the stack will be updated to wherever the current was inserted. Sorry, the top of the stack will be updated to whatever now element, wherever now element was inserted. So where it was inserted, whatever the previous value of next available index was. So this is how I'll update that. And then there's a cycle here actually. Yeah, I'll take this next available index into a temporary variable, then change it. Then I'll change next index. Then I'll change top. Top of stack. Then top of stack will be again changed to temp of index. So this is how my push operation will work actually. I'll share the code. You can go through it once. Then I think it will be much clearer actually.
Yeah, I think we can ask questions in Discord, or like if we have going through the code.
In the Discord, we can discuss. Actually, it's much.
Yeah.
So similarly with the pop, there will be a cycle here. If you want to pop, first you'll take the top of the stack, store it in a temporary variable. Then the top, once you're popping, your top will be decreased, right? So wherever was your previous top, that the top will be updated to that value. So your previous top was stored in next index. So it will So top of index, top of stack will be updated to that. So and now the next index will change to what whatever value was there in the next available index, because another space is empty now. So this line number 28 next index will be updated, and now the next available index will get updated to whichever the current element was popped out, because that is now our preferred empty location. So that will be the index in which the new incoming inserting element will be stored. So we'll assign that value to the next available index. And this is how our pop operation will work.
Okay, cool.
So yeah, I passed away the code quite in very fast, but yeah. Did I make any point something or?
Yeah, I think yeah. I mean, what I felt is that when I was doing this question, like it took me some time to understand this after looking at the code.
Similar happened to me actually.
Yeah.
I had to analyze the code by pen and paper. After that, I got the crux of the question. Yeah, same happened to me.
Yeah, maybe you can post your code and then we can go through it.
Yeah, sure. I'll do that.
Thanks.
Yeah, so we can discuss over Discord if anything, because it's already past time now. Yeah.
Cool. Thank you.
Yeah. So that's it from our side, I guess. Yeah. Thank you so much. Thank you so much for letting us have a session here.
Yes.
Yeah.
Thank you
Thank you so
for
much.
guiding.